So good morning. Let's start the module 2, multi-threaded programming. There are 3 chapters, chapter 4th, 5th and 6th in this module. So chapter 4 will discuss about the threads, in that multi-programming concepts. Okay. Chapter 5 will give the knowledge about process scheduling, whereas the chapter 6 will be the synchronization. Okay. So now let's start the chapter 4, that's threads, in the unit or the module called multi-threaded or programming concepts. Okay, so let's see what you mean by the threads and all. Okay, next, in this chapter 4 what we are going to cover is some definitions. Okay, so after that we can see multi-core programming, then comes multi-threading models, different types of models. So you can expect this question for in examination for about 6 to 8 marks, definite question. Okay, so with the diagram it is there. Okay, then you can expect threading libraries, because there are some programs as the examples. Okay, so these two extended concepts. Okay, so now what we will get from this particular the chapter is some of the applications, how the multi-threads are executing. So what is the advantage of executing an environment in a multi-thread way? Okay, so how to work with different threads like user thread and kernel thread, and how the heavyweight threads are created or light threads are managed, etc. Okay, so let's go for first some 2 definitions. Okay, so what do you mean by thread? It's a flow of execution. Simple word, it's a flow of execution. And also it is called lightweight process. Okay, lightweight process. Now we had 2 definitions, or the differences between program and process. Okay, so program means it's also process which is presently not executing, whereas a process means it's a task which is presently executing. Now, is it possible to subdivide a process, okay, into smaller definitions? If yes, those are only called as thread. It's a very small process. Okay, lightweight process. Coming back to the definition, thread is a flow of execution. So whenever we get a word flow of execution, so what are the 2 or 3 important words is associated with this? We have to keep a track of which process has to execute next. Because what do you mean by flow? If I organize one sports event, or we organize a sports event, so what will be the flow of a program? First, inauguration. So there will be a speech by a specific guest, okay, who is to motivate all of us to participate in the sports. So then sports activity 1 from this time to this time, sports activity 2, second slot, third slot, etc. So that means here what we should have a proper execution flow. So first activity number, then second activity number, last activity number. Also we should have how much time each activity should take place. So this thread is called a time dependent execution of the tasks in smallest manner or smallest time slot. So if we should maintain a flow, then we need one important keyword called program counter. So what is the definition of program counter? It's a pointer which points to the next executable instruction. Hence, thread is flow of execution through the process code. Okay, that means how we have wrote a code with its own program counter, which holds address of the next executable instruction. Okay, next, multi-threading. What do you mean by multi-threading? Here, very simple way, if we have 2 or more than 2, okay, threads at a time, it is called as multi-threading. Okay, if we have two or more than two threads at a time, it is called as multiple threads. Now I will show you one diagram in advance, so you will come to know what is a single thread and what is a multi-thread. Okay, this diagram is also important with respect to the exam point of view, also with respect to the concepts. See, the left window or the left box is of single threaded process and right is multiple threaded process. So if there are multiple threads at a time, it is called as multi-threaded process. So now the question, what each thread is, okay, should we what all the resources we have to reserve for a thread. Once a thread is present, thread means it's an execution. It should have its registers for participant values or variables, also resultant variable where we should store the results. It should have a stack for push or pop operations or link register from main to subroutine, subroutine to another subroutine, or sometimes from main to subroutine, subroutine back to the main. Okay, so each thread will have its own code. So code means what? Code area means what type of instructions or what set of instructions it is executing. So what do you mean by data? Data means on what variable it has to execute. Say, let's say take one example, C is equal to A plus B is one operation. So here what are the instructions and what are the data? First let me give you code or instruction. There are two instructions or two code. One is plus, and after getting the result another one is equal to. Whereas data means there are two variables initialized and one variable which is used to store the result. What are the two variables which we have initialized are A and B. The variable in which we are going to store the result is C. So next comes files. Files means what? From where we are fetching a data to where we are storing a data on secondary disks. So those are called as the files. So for one thread, these all are required. Next question. So if we have multiple threads like in a second diagram, okay, so what are the minimum resources we have to provide for each thread, and what are the resources which are going to used which are available only one, and those should be shared by the multiple threads, that we have to discuss. So second diagram, you see there are three threads. So each thread has, see the diagram, vertical distribution. See this, thread 1, thread 2 and thread 3. Thread 1 has its own stack. Thread 1 has its own registers set. Similarly, thread 2 and thread 3 both have their separate stacks and separate registers. But once we come across all the threads, there are no separate code area, data area or files area for each of the thread. Instead, we have a shared block of data where I am moving a cursor. These content are common. So if these are common, the threads should share among themselves. How it is possible to share among themselves is the third point which we are studying in this chapter, that is called as process scheduling. Okay, now can threads have their separate stack? Yes, threads can have their separate register, but threads cannot have the resources like code, data and files. They should share among themselves such that there won't occur any of the disturbance. Now the question, if single thread is there and all the resources are available, so then this thread will never feel any difficulty. Whenever this thread wants, he will enter a code. Whenever thread needs, he will enter data, he will fetch files and all these things. Now if there are multiple threads, what is the first option we have is, so first option is when thread 1 is allowed to enter code, when thread 2 is allowed to enter code, when thread 3 is allowed to enter code. So to monitor all these activities, because there is a sharing resource, there should be someone who has to monitor and give entry, exit, access, okay, not permitting. All these should for each thread for common resources management. So that management is done by operating system, okay, like Android operating system or the Windows operating system or the Linux operating system, etc. Okay, so now the question, if we have, okay, here, if we have more than two threads at a time, so now it's a responsibility of operating system to manage them. Okay, so now the question, who has to manage the management is done by operating system. When it has to manage, when there are more than one user. Now the question, so generally what we should think as a threads, so generally general perception, one thread means one user. Okay, say now just imagine I will type Google and I will hit now live cricket score. So like me, how many people will type live cricket score to the Google on this complete earth right at the time when I have also entered? So can I say or assure that I am the only person who is searching a live cricket score at any moment using Google? So no, I cannot assure. Many people on this earth may try to search live cricket score on the Google at any time. See, Google is providing service for cricket score type of user. So also one more person may come, he will try to search for some IEEE paper. One more person or group of people sitting here and there or different geography, they may search for some paintings, etc. So totally what happens with respect to Google, every minute or every second of a time, so operating system has to manage if there are two or more than two threads at a time. Okay, now what are the benefits of having multiple threads is, so first a benefit is responsiveness. Okay, so responsiveness means continuously interactive. So if it is interactive, any process has got any difficulty in continuation of execution, because of responsiveness it can attend that problem and solve the problem. So what happens if the multi-threaded or environment is not responsive? So what happens, since there are multiple processes executing at a time, any particular process or a thread has suffering a problem or shortfall of a resources, and it responds that I have to continue the execution, I need this type of resource. So if operating system or the multi-threading environment both are not responsive, so the problem is not going to get solved. So the thread or the process is unable to finish its allocated work. So like that every process will lag their execution. So finally system end up with no output. Okay, so also what is one more important with respect to the multi-threaded environment is, since there is a common resource like a code, data and files, okay, we cannot provide every thread a separate copy. So there are only the one copy of resources are there, so definitely they have to go for sharing of the such resources. And also since it is a sharing of resources, so it is also called economy. Why it is economy? Because if you start providing separate copy for data and separate copy for copy of data, copy of code, copy of files for every thread, so definitely hardware will be more. If hardware is more, expense of or total system will be of costly. So next one is scalability. So since there are multiple threads executing at a different time or different slot of the time, okay, so what happens is we can add, attach or detach any type of the hardware. Okay, so thereby once we attach or detach, it is called as a scalability. A particular thread who wants extra hardware, it will execute and it will complete its task using the extra hardware we have connected. Okay, so this is what environment, benefit of the environment. Okay, so next, multi-core programming. Okay, this concept only for the next diagram help I have kept. Okay, so next, data parallelism and task parallelism. Data parallelism means between 2 or 3 processes data is shared. Okay, please remember, same data is shared, whereas in the task parallelism, some data will be common. It is the output of some thread is shared. The output of some thread, which is we call it as a result, is shared for next few threads. That is called as task parallelism. So very simple. If we organize a sports game 1 and game 2 parallelly at the same slot, it is called as task parallelism. Okay. So now here one thing is, what happens if we execute with a single core? What happens if we execute with a multiple core? Single core means what happens? All the threads will go for execution one after another. See here, first 1 2 3 4, again 1 2 3 4, again 1 2 3 4. That means what? There is only one channel or only one entry door, exit door. You have to follow that way. If there are a multiple core, what happens? We can give 1 3 for one core, 2 4 activities for second core. If we have one more, how we can divide? 1 2 3 like that, again 1 2 3, or 4 5 6 7 8 9, like that we can give the order. So what happens here? See, this is a single data core. Here it is a multiple data core. So each core can execute allocated tasks. Here task 1 and task 2 will execute parallelly, task 3 and task 4 will execute parallelly. Hence that continues. This is called as task parallelism. Okay, so this one I have already explained. Anyway, what happens in a single threaded process and what happens in the multiple threaded process? Single thread means there will be only one thread. It has its own registers, stack, code, data and files. So no other thread will compete or make a competition to get access over these. So he is so whole and sole for all these resources. Whereas in a multiple thread means there will be 2 or more than 2 threads at a time. So they will have few resources separate for them, but few resources are common. Who are separate, they can use on their own, but who are shared, they should be well managed, which is done by operating system. Okay, so now how many types of threads are there? One is a user thread, another one is kernel thread. So user thread means if I want to search live cricket score using Google, whatever I give through that search engine called live, LIVECRICKET like this, I will give cricket score. So that request is called as user thread. So what kernel will do, it will try to search some other servers. Google server will try to connect, establish with some other servers like IPL server, some big bash server, some other cricket tournament server. It will try to make a connection. So what that servers will do, they will fetch current live score and give it to me or show it to me. So here what happening, the user kernel, what I have used for requesting kernel server is to provide the service by getting work done by the audit. Okay, examples for the user threads. So first user thread is POSIX. Okay, these are called as pre-threads. See, please remember the full form: portable operating system interface. Portable operating system interface. Okay, so Windows threads are there, Java threads also there. I hope you are going to study these Java threads in your OOC subject. Okay, next, what do you mean by kernel threads? Kernel threads means what? Who provide the service for user threads. What do you mean by user thread? Who will give or who will request for the service. So just like I am requesting to know the live cricket score, Google is providing me service with the what is the current cricket score. Okay, some examples for kernel threads are Windows. Windows has a both. See here, Windows has kernel threads, Windows has a user threads. Why? Because so if I start to use MS Word or MS presentation, PPT presentation, Microsoft, okay, what happens? I will click on something called a draw table, something called insert a image, etc. So these are user kernel. So what the MS Office or MS Word, MS presentation will give me back is, it allows me to draw the table, it allows me to insert a picture in my PPT presentation, etc. So here both are interactive. So that's called as the both threads, Windows threads as well as kernel thread. Okay, so now how many, okay, now the condition or the next point is how many types of multi-thread models we have. There are three types: many to one, one to one, many to many. Okay, there is one more derived type is there, that also we'll see. So first point, very very important, I think I have given you the importance with respect to the marks here. Okay, models, this one. So the third point, multi-threading models, which the question you can expect it for 6 to 8 marks. Okay, now here. So there are three models: many to many, one to one, and sorry, many to one to one, and many to many. So let's go for many to one. Now the question, many to one. Here, best example, Google. So what I say, what I tell you is, so I will start one in that session. I will explain something to you, some concept like drawing or some game, anything I will explain. So next, what I tell you is, all of you go for Google search engine and check the importance of the concept what I have explained. So what you will do, you all will start logging into the Google. So you will provide same content search. So like say for example, live cricket score only. So what I tell you is, everybody go and search in the Google what is the live cricket score. So what everybody will do, they will open up a Google server and they will give request live cricket score. So how many users are giving the same request right at that moment? Hopefully around 40-50 members will do. So what happened here? So we feel like all 50 are getting separate work, but internally all are requested for the same for our college server. So what college server will do? It will collect a request from all. Since request is 100% same, it made it as only one, because all 100 people or all 50 people are searching for live cricket score at exactly same time. So it makes as all request as one. So many people thought that they are only the searching person, okay, or they are only getting that result, but internally, since they all are searching as the same result, it will forwards that into one, which is called kernel. So because kernel will do, what college server will do is, server will forward your request to the Google. So Google will give you the answer, and once the kernel server of our college gets the service, it will again broadcast on your monitor. So what we will feel, I have the computer is working for my request only, I mean college server. Actually it is working for everybody's request, whatever they are doing. So another case, so exactly 10 o'clock I will also log in my college computer, some other staff will log in, some students will log in. So I will search for some operating system study material, other staff will search for his subject, some students will search for some of the notes of different subjects. So we all will give us a request at same time. Okay, what happens next? Our college server will collect it and it will forward it to some of the related servers. So it will collect the data and give back to us. So meaning is what here, college server acts as only one, but we feel that, okay, I am only getting a service. Okay, that's what the meaning of many to one. Many user threads will forward their request to one kernel thread. So where this system is available, it was present in Solaris green threads, where many users they request and they will do. One more exact explanation let me give. Assume that 4 members, 4 friends are doing one project. Okay, one project. Okay, they do tasks separately, but their result is going to store in some common space, because they are doing one project. In that, sub activities are different, sub activities may be different, but thing is like they have to update in the same area of the memory or same area of the computer resource. So here what happens, even though their activity is different, so there are different threads, but they are going to update the answer in same data area, hence it is a common. So what happened here, many to one. So what is the next one, one to one. Okay, for every one user there will be one kernel thread. So this is little costlier, because we should have many kernels, many kernel threads at a time. But one thing is, it will be faster. It will be faster. even though it is a costlier, but it will be faster. So each user thread maps onto one kernel thread. So what happens, I will search for what you can say is in my computer, in my home, I will search for live cricket score. In student 1, he is sitting in his home, he will search for some textbook. Student 2, in his home, he will search for some other content like music file, etc. So what happened here, we all are sitting separate, we are requesting. So what happens here is, so even though the threads of user is different, every request is handled by separate kernel threads. So what happens here, so the service will be fast. Okay, so because the service is fast, because separate user has a separate kernel thread, so we can expect execution faster but costlier also in the execution. So what are the two type of OS will provide, Windows and Linux. Okay, next one, many to many. So it is a hybrid model. Okay, so one more is there, this one, it's also hybrid. Here it is a derived from first two. One is many to one, second one is one to one. So here what happens, so randomly some threads are created by user, randomly there are some kernel threads, there won't be only one. Okay, so here any thread can be linked to any of the kernel. Also any two threads, any two user threads can be mapped onto any one kernel thread also. Say the case, there are 4 students who are searching for something in the Google. So student 1 and student 3, they search for IPL live score. Student 2nd will search for some notebook. Student 4 will search for some music, notes of a textbook. 4th. So what happened here? See, there are 3 kernels. What happened here? Let's assume 4th student request, what he was doing, music file, it is controlled by this kernel thread. So this one fellow, 2nd student who has requested for some notes, it is provided by this. Okay, so next what happens, the 1st and the 3rd students who were searching for same type of content like IPL cricket score, so both are same, both are merged and given into a common kernel thread. Okay, so that is what many to many. So I repeat this question because of importance. One is multi-threading models. So multi-threading models, please include this diagram also because the question is for 8 marks. First you explain this. So multi-threading, single threading means this much, where there will be only one thread. Okay, he has all the resources available for him. In multi-threading model, there are multiple threads, few resources are separate for each of them, few resources are common, they should share among themselves. Then comes the models. So there are 3 models, many to one, one to one and many to many. First is many to one, where almost all resources are same type, almost all requests are same type, where 4 students are doing same project but different work, sub works. So if they get all same type of if they get their result of whatever they are doing, finally they have to store it in a same area. So for that they are going to share the resource. Okay, so which is controlled by common kernel thread. One to one, since there are separate multiple user threads and multiple kernel threads, so one user thread is mapped onto one kernel thread exclusively. So this will be faster but costlier. So coming for the last one, which is a derived method, many to many model. So there will be many number of user requests and many number of kernels, many number of user threads and many number of kernel threads. So looking into which are similar type of user thread, they are mapped onto a common kernel thread. Which are separate, they are mapped onto individual kernel thread. So there is one which is a hybrid technique, 2-level model. Can we have one to one also many to many, one to one also many to many? Yes, this is possible. It's called hybrid technique. So see the case, this thread is ready to give any cost. Okay, and it doesn't want to share his information with any of the kernels thread. So what it will do, it will give the request, one kernel thread will be created and mapped to both, and this thread will always get work done by this. Okay, so examples for this, let me give you. So what you are doing is, say for example, in a Google Chrome, you have opened music file, music environment, Google, then some of the file download, and last one is banking activity, like finance transfer. So what happens, banking activity or transferring the money, this is very important compared to all other. So that time what happens, so the banking activity will be managed by exclusive kernel thread. So no other unauthorized access or hacking of a data should not take place when you are doing multiple works. What about remaining three activities, like downloading IEEE paper, searching something in the Google, and downloading a music file? They are common. There is nothing called hack, or even if it is hacked, nothing is going to happen. So such activities are handled by common kernels. Okay, common kernels means group of the kernels. So when some of the activities are very important, and that is managed by separate kernel threads. If some of the activities are normal activities, then it is managed by group of sharing type of kernel threads. Yes. Okay, let's see now the next important heading, thread libraries. Here also you can expect a 5, 6 or 8 marks question, which I have mentioned in the initial portion like this. Okay, here you can see the importance. So thread libraries, it's a program explanation. Okay, I'll try to do this so that students can rewrite the program, able to rewrite the program in the examination if it's been asked. Now the question. Okay, simple question. What do you mean by book library or the library? First definition, libraries, it's a collection. Okay, so collection of what? Library. Music library means collection of song. Photo library means collection of photo. Books library means collection of books. Same way, thread library means collection of threads. So next thing, collection of thread, does it only mean maintaining whatever is existing? Okay, so the meaning is, we have a library in the college, so does it maintain the same textbook every year, or they are going to add new or delete something from the already existing? So it is like, first manage if existing, managing all the existing textbook. If any student will request for a special textbook for his extra study, then try to add that into the library section and give it to the student. So if some book is not useful, or like, don't say not useful, so its tenure is over, then we can delete that book from the library also. So same way, thread library is also to create a threads and manage the threads. Okay, why we should have creating a thread and managing thread as important concept is, see, if something new is required, something new is required which is not available right now, it's called create. You will go to library and you will request for a file that you will request for a book. If that book is not available right now, means should we say that book won't be available from the college? No. So what we have to do is, we have to take up the request and buy the textbook, keep it in the library, so that student will get a knowledge from the textbooks. That's called creating. So once it is created, does it important to manage? Yes. See, a student has given with that book. Okay, so after some time, some days of a time, so he has to give back, make a renewal, or give it to any other student. So that is what called as management of the books. Same way, management of the threads. So now, there are two types of library threads or thread library. First thing, user space is different, kernel space is different with respect to threads I am telling. So that means what? Let me say one real world analysis. So there are two type of students, student category 1 and category 2. So what category 1 student will do is, they will bring some textbook from the library and some textbook for their own and keep it at the home. So what happens for that particular student? So some may take a Xerox of a textbook, some may get it from the library. So here the meaning is they will have their personal library. Who is that? Who is the user? So same way, so keep the entire library in a user space. That's the first method. Okay, so what is the advantage of having local library? Means in my library of this semester in my home. So here the meaning is, first thing, it is costly because I have to bear that cost. Second thing, it will be faster. Whenever I feel to study a subject, I will open the textbook of that, I will go to that chapter and I will get a concept. Okay, so here is a that. Okay, so this means right. Okay, here the code and data is copied onto user space. Meaning is what? Whatever is required, it is given for the user separate copy. Okay, so what is the advantage? So it is a local function. So what user will do means student will do, he will take up the book whichever he wants to or interested, open the chapter and study that subject or concept. So what is another way? Kernel level library. So if you are not interested to keep all the books copy in your home for your reference purpose, what is the option or default option we have? Keep it in a college library. Whenever you want, you go to library. If book is available, you will get. If not, you have to wait and you get it after some days. So what happens here? Keeping a code and data separately, common in kernel space, not separately in individual space. It is there in the college library. You have to visit, get the the textbook. Same way here, kernel space is common for all users. So in there data is available. So use the data. So when you are using, you should go with a system. System means a procedure is there. According to that only you have to follow. So go to the college library, give your ID card and get the book. Okay, after some day you return. Are you going to do same procedure if the book is available at your home? Are you going to give some ID card to the rack or something and get the textbook at a home? No. So directly go and refer. So library in the user space is free of procedures or protocols, whereas library in the kernel is according to the rule we have to follow. So coming for the next, so this is a definition. So I repeat one for a while. So thread library means creation of and management of multiple threads. Okay, so two types of libraries are there. One is local library, which is a user space. One is a kernel library, which is in the kernel space. So local library means separate copy of data and code will be given for each thread. Okay, but it is costlier but more fast. Okay, whereas kernel means there will be a common space in that it is been provided, means it has been kept. So all users should access them only through the proper channel, that is called as a system call. Okay, there are three types of libraries, thread libraries. So all three are important. You may get question from anyone. So according to my view, POSIX thread program is of more important because it's a student level. Windows and further are little enhanced. So as my view, POSIX thread question you may get it in the examination. So now the question. So what do you mean by POSIX threads? So first thing, what do you mean by POSIX is it is going to happen only in the Linux type of environment. First and foremost important, Unix or Linux type of system. So what are the other type of systems which will provide Unix or Linux are Solaris and Mac OS X. So these are also okay. So since we all are not much familiar with the Solaris and Mac OS, we are studying a Linux also. So I will take up the help of Linux knowledge what we have and try to explain few. Okay, so what do you mean by P threads? Okay, here you see P threads, that means POSIX threads, portable operating system interface. Okay, so that's given by X. Next, so here threads or their thread library can be kept either at user level or in the kernel level. There is no rule that it has to be only in the user level or kernel level, like how we have seen that thread libraries two types. It can be anything, so it can be both. So what is how the POSIX threads works? POSIX threads works based upon IEEE 103.1c. okay, and these are used for creation and synchronization of the threads. Okay, not for implementation. Not for implementation. If you want to develop the work or done the work, working portion should not be in the execution part should not be in the P thread, whereas creation and management can be the POSIX thread, can be done through the POSIX threads. Okay, so the next one is, okay, behavior of a thread library we can study. Behavior of a thread library we can study. So I will take one example which is given in the textbook as a program. I'll try to explain in detail so that the student can understand how the POSIX thread will work. Okay, so one or 2 points let me give you about POSIX threads as a repetition is P threads are created in Linux platform called POSIX threads. Okay, so these are preferably used for execution, not for implementation, instead management. Okay, so there are the creation, deletion, free and termination. These type of activities we can do with the help of P threads, but implementation part we have to go with Windows or Java type of threads. Okay, so now let's go for one important program which you can expect here. First I will try to give you how this program works. Later what is the purpose of the program. Later I will explain you how this program works. Okay, this program has one important concept, that is user defined function. So there is one, let me give you in terms of symbol. Okay, this program will do for positive numbers, that means 1, from 1 to n, it keeps on adding the numbers. Okay, so starting from 1 to the n. Here there are 2 to 3 sub activities. What are the activities? Here you see, let me type and give you. First activity is initialize variables called sum equal to 0, I equal to 0. Okay, so that's next. Also there are something called check whether limit has reached or not. Okay, so next one more work is there, calculate sum by adding numbers. How? Sum equals sum plus I, like this we have to add. Also we should not forget to keep changing the, here like this, keep changing the value of I by +1 every step. Keep changing the value by +1 every time. Okay, this is one activity or program. So I repeat, starting with the 1 till it reaches the upper value called n, go on calculating the variable plus, like sum equal to sum plus I, and also check I whether it has reached m or n value or not, and also keep changing the value of I. So this is one concept. What you can say, summation from 1 to n, sum of numbers series from 1 to n. So now how it works, see, please leave this if part of 2, argument not equal to 2 and argument variable 1 less than 0. These two you can skip. These are not that much important because we are beginners of the thread programming. So we can skip these two. Once we are expert, or once we understand thoroughly, then we can include them. Since it is the first time, I am leaving those two part. So there is one variable global variable. Please remember this, very very important. It's a global variable. Like if we used to write hash define sum equal to 0, or hash define pi 3.154, I mean 3.14, like that. So same way int sum. And I am going to use one UDF pointed by pointer, means UDF controlled by pointer, and name of UDF is runner. Okay, so this is a prototype. These two are prototype. Main program will start. Main program will take main argument variables. So here are the two important activities. Please remember this. Okay, so pthread underscore t of TID, task ID or thread ID. TID means thread ID. Like how student has USN, same way each thread will have their identification number, that is called as thread ID. So thread ID is created. So then set attributes of the thread. This question is important. If you take admission in the Jain College CS department, so what are the attributes you will get? First thing, you are going to get a USN starting with the 2JH, that is the first thread. Second thread, you are allowed to use college bus, you are allowed to use college library, you are allowed to access the college canteen. See, these are the attributes. So what else are the attributes which you can say once you take admission for the Jain College? You can go to the CSE department, use the computer and etc. These all are the attributes of a student who belongs to Jain College CSE department. So what are the attributes for Jain College student mechanical department? So can he use the canteen? Yes. Can he use the college bus? Yes. But can he use a computer science department computers? Not possible. Okay, exception case is there, C programming lab, but every day he cannot come and sit there. Okay, so here can he use mechanical department lab equipments or some machines? Yes, because he is a mechanical engineering student. Like that, some attributes are initialized. Those are very very important. See, if it is initialized, does it mean he should use? No. Sometimes what happens, there is a student who doesn't want to go to canteen, or he doesn't want to come by college bus, so he wants to travel every day by his own vehicle. So what happens, attribute is there but he is not utilizing. No problem, it is initialized. Using or not, it is up to the process. Same way once thread is created, he has given with minimum features. Okay, so what happens in special case? See, now the case is like this. During some placement program, okay, normally what student can do with the computer, he is allowed to use computer, monitor, CPU, keyboard, etc. So there is some case called project exhibition. So what the student will do, he can use extra equipment called projector. So through that projector he can explain to all the resource person who is sitting over there in his session. So like that, attributes keep changing on based upon the situation. Okay, so next, so who will manage this thread ID and thread attribute is done by POSIX. Please remember, POSIX operating system will do this. Next, here I told no, pthread underscore attribute underscore init. Init means what are the very minimum attributes for a student of Jain College CSE. What are the minimum things? First thing, he has a USN with a 2JH CS. Then he is allowed to use, he is allowed to sit in the CS class. He is allowed to come at 8:30 to 3:30. He is allowed to use the canteen. These are the minimum. So once he reaches 8th semester, what is added feature for him? He can use projector for his presentation. Okay, these are extra features. But what are default or initial features which a student will bear when he is in a first semester? Okay, next what happens? Okay, this comes a join. Okay, join means add-on, extra add-on. Okay, before joining and init, there is one work called create. Okay, create. See, now the question, we have to add something, we have to get work done by him. That is called 4th semester. Let's say 4th semester. So 4th semester the student has entered and he has to demonstrate one program called stepper motor. Okay, run a program called a stepper motor. So to run a program called stepper motor, what he should use computer, he should use a stepper motor device which is not available in open market, which it is available only in school environment or college environment. So what he has to do, he has to execute one program. So what his extra feature now added, is he allowed to use a stepper motor? Yes. Can he use the same stepper motor when he enters a 5th or 6th semester? No, that time feature is deleted for him because he completed that exam lab subject, so he will not use. Also it is not allowed for him to use with he can use but only with the special permission. Now like that, what is the work for this program is, see now, when pthread is created, it has been given with what is his ID, what are his initial attributes, what he should do. So as I mentioned in general, he should do the stepper motor program. Now in this program, what process should do? He has to do summation. So how the summation should be done? Here you see, I think yes, here. So summation, see, this is a runner. I told you here runner function. So how the runner function will execute? The main thread, see, very important statement, up to now only there was one process called main. Okay, main has created, in the main only thread ID created, in the main program only thread ID attributes are defined, in the main only thread attributes initially are calculated. Now it is going to create one more thread called runner. So as this time, how many threads are there? As at exactly at this time there are two threads. One is a main thread and another one is runner thread. Okay, who is a parent? Here main is a parent, runner is a child. Okay, so now can you stop main before the runner finishes? No, that means parent has to wait. So who is executing? Child. What is name of child? Runner. So now what runner will do? Runner will do a parameter called 5. Let's take 5. So what is I? 0. Upper 5. Forget about this ASCII to integer. Leave 5. Sum is what? 0. For I equal to 1, I less than or equal to 5, I plus plus. Sum equal to sum plus I. Okay. So what happens? I equal to first 0 plus 1, next 1 plus 1, next 3 plus 2, next 5 plus 4, next 9 plus 5, total 14. 14 answer is done. Now listen carefully. Who is calling pthread exit? Who is calling pthread exit? It is the child whose name is runner. So what happens at this time? Thread finished calculation of the answer sum and the answer is 14. Okay, so the answer is 14 and the child thread whose name is runner completes his execution and dies. Dies means he is dead. He is dead. So now who is still waiting? Main. So main will get an answer called 15. So what main has still work, still some more work. He has to join himself with the child called runner. So both are joined, and when joined, he will, when the child kills itself, he will get back the answer called sum as 14. So 14 is returned back to main. So what this line will do? Who is executing by main now? It's a sum equal to 14. So actually who has calculated sum? Actually child has calculated sum, but who is printing answer? It's a main. Is it clear now? So POSIX thread main is created, POSIX thread main called, second thread called runner, runner thread executes, runner thread will finishes execution, then runner thread will give the answer back to main thread and runner thread will destroy itself, then comes main thread prints the answer, and finally main thread also kills itself. So this is how the pthread works. Hope it is clear now. I repeat it once again, whichever are the important points. So this program executes for summation of 1 to some limit. Okay. So first thing, there are two type of important variables. One is a sum variable and another one is runner, which is about to get it as child thread. So main program starts. So main thread is created. So main thread calls one more, itself thread ID and attributes. Thread ID and attributes. So next it starts with the thread basic initialization. Thread basic initialization. So in which minimum facilities or minimum features are added. So thread calls one more thread creation. This is important. One more thread creation. His name is runner. So runner main thread calling his child called runner thread. So runner thread starts execution by accepting one parameter, which is a value something like 5 or something like 10. So both will start execution, but main is a small time pause, means inactive, but not at died. Okay, so sub sub thread or child thread whose name is runner, he will calculate a value of sum from 1 to the upper limit, and he will destroy himself using pthread underscore exit. Also before he destroy himself, he will give back the answer to the main. So once this program or the child thread whose name is runner destroys himself, then main thread will receive all the answer. Only one answer is there, that's a sum. So finally child thread is over now. Main thread who was little asleep, now he is active and he will print the answer of sum, and finally he will also closes himself. So this is what pthread example. Okay, so here what are the 2 to 3 important points here? The thread creation and thread management, thread termination, everything is done using pthread library. Pthread underscore, here you see pthread underscore create, pthread underscore join. Again here also, okay, these are pthread underscore attributes. So this means what here? All the activities we have done through pthread library. Hope it is clear now. So this is how the explanation for pthread. So this is up to today's session. So tomorrow session again I will launch one more video. Please refer.